All right, what you currently see on my screen, you don't need this. You're not going to get this, but I'm going to, like you're not going to receive it. Not that you won't comprehend it. The word get has different meanings, right? So I'm not trying to insult your intelligence by saying you're not going to get this. You just won't receive a copy of it. That's what I mean. Didn't seem like anyone was confused over that. Okay, explanation not needed. All right, here we go. This right here is called Pascal's triangle. It's pretty cool. What it does is, well, one of the things it does, I'm sure it's used for other things, but I don't know what it is that it helps you identify the nth term of any binomial raised to any power. And I'll show you how it works in just a second. We've been expanding binomials like this for a very long time. And if you were to expand this binomial by FOILing, this is what your result would be. Okay. If you took a binomial that is cubed, then every now and then we expand those, and it takes a little bit longer. But if you were to multiply this out, this would be your results. Every now and then we have one that is to the fourth power. I don't think we've ever really had to expand one of those because it takes a really long time. It's confusing. Anyway, if you were to do that, this would be the result. Well, what we're going to be doing today is you'll see a binomial like this, and it'll say, what is the fourth term of this binomial? Well, when it's written out here, like this one, it's very easy to tell what the fourth term is. I've already put it in order for you. 1, 2, 3, 4. So if we were to ask you, looking at this binomial, what is the fourth term of this binomial? Your answer would be 4xy cubed. If you were to do this algebraically, you'd have to do x plus y times x plus y times x plus y. It's going to take a long time. That's not what we're doing today. If we had Pascal's triangle, here's how you do it. If a binomial is being squared, then what we do is we go to row 2 of Pascal's triangle. This is row 0. This is row 1. This is row 2. And what it tells you is it tells you what your coefficients are going to be. They're going to be 1, 2, 1. 1, 2. Jumping over here, let's go to this one now. The fourth power binomial says go to the fourth row of Pascal's triangle, 0, 1, 2, 3, 4. And all these numbers will tell you what your coefficients will be: 1, 4, 6, 4, and 1. So if we had to expand this binomial to the sixth power, well, we at least know what our coefficients are going to be. We go over here to row 6, and they're going to be 1, 6, 15, 20, 15, 6, and 1. We know what the coefficients are. Well, if you study the pattern here of your variables, they also follow a very predictable pattern. Looking here at the fourth power, well, if the binomial is to the fourth power, then it's going to start x to the fourth, x cubed, x squared, x to the first, x to the 0, which would just be 1. Anything to the 0 power is 1. And then your whatever your b value is, in this case, it's a y. It goes backwards, y to the fourth, y cubed, y squared, y to the 0. So we already know what these variables are going to be. Since this is the sixth power, a sixth power binomial, it's going to be x6, x5, x4, squared, x, and then x to the 0, no x at all. And then backwards, it would be y to the 6th, y to the 5th, 4th, cubed, squared, first, and so on, right? Now, there's also another pattern that these variables follow. They all add up to whatever the power is of the binomial. So since this is a sixth power, then this term here, it's going to be x to the 6th, y to the 0. Those exponents add to get 6. Here, 5 and 1 is 6. Here, 4 and 2 is 6. Here, 3 and 3 is 6. See? So if we were to say, hey, what is x plus y to the 8th? We could go to row 8, find all the coefficients, x to the 8th, x to the 7th, x, and just go down the line, and it'd be pretty easy, right? But as I mentioned, you're not going to get this diagram today. We're going to learn how to do it using magic. I mean, the graphing calculator. That's what we're going to use, which is kind of like magic in a way. So everybody put on your magician's hat. I don't know why just the image of that just made me it just tickled me. We all had magician's hats. And of course, it'd be the type that like it's flat, you know, and then when you, right, you ever seen that? Excellent, okay. Can I help you?
Yeah.
Oh. There, it's fine. That's what these calculators are for. So you can use them in case they die. What are we doing? Thank you. That's all you had to do. You just showed me this, you showed me calculator, I know exactly what we're doing. Okay, looking at example 1 of your notes today, it says find the 4th term in the expansion of a plus b to the 5th power. Here's how you're going to start it out. First, observe the power. So we're going to start with 5. And then we're going to write down these letters. And then you're going to observe what term do they want us to identify. In this case, 4th, whatever the term is, subtract 1. 3. This is what we're going to plug into our calculator. I'm going to show you how to do it. Second quit. There we go. All right, we'll start with the number 5. Then you're going to hit math. And scroll over to PRB probability. And then go and look for that NCR button. Enter. Now 3. Enter. So here's what that tells us. Remember that? Remember Pascal's triangle? That's the coefficient that we need. 10. Now go back to your binomial here and look at the very first term. It's A. Then look at the second term, it's B. Now watch this trick. Whatever the last number is, that will be the exponent of the very last term. And remember, your exponents got to add to get to this exponent here. So then this one must be squared. That's your answer for example 1. Try example 5. I'm getting it. Yes, example 5, please. Oh. When you used your magic calculators, did you get 56? Good. Remember, the pattern is whatever the exponent of the binomial, 8, NCR, and then whatever term we're looking for. In this case, it was the 4th again. Whatever that term is, subtract 1. All right, so we have our coefficient. Start with the A term next, then the B term. Remember, whatever that number is, that last number, it will be the exponent of the last variable. Since these must add to get 8 in this example, then A must be raised to the 5th power. Easy? That's all we're doing. That's it. Good. You know, you only got like 50 problems like that on your Delta math. Pretty easy. All right, let's look at example 6. Let's start out, let's not panic. Number 1, don't panic. Doesn't look like any of you are. Good. Okay, example 6. Let's start out the exact same way. Start with the power. And then NCR. Looks like they want us to find the 5th term this time, so subtract that by 1. Let's plug that in. Okay, so far we started the same way, but now our A term is 3x. That's okay. Just write down 3x. Our b term is -1. That's okay. Just write down -1. Follow the same rules. Last number is a 4. That's going to be the exponent of the very last term. These exponents must add to get 6. So this has to be 2. Now we just have to do a little bit of math. So start with 15. 3 squared is 9. X squared is x squared. -1 to the 4th power is a +1. And 15 times 9 is 130. What is 15 times 9? 135. Yeah, 135. 135x squared. That's your answer. Try example 7. Try example 7. We get it? That's it. Submit your notes on Canvas. Go to Delta Math. Do the, oh, there's actually one thing I forgot. Do those things too. But if you were present on test day, this last test day, and you scored below 70, that was a tough test. Don't beat yourself up. We're going to actually retest in class today. I'm going to open it up for all of you that happen to score below a 70. There's not going to be any test correction. So if you want to improve up to a 70, just do the retest. You don't have to put your phones away. You can ask me for help. It should be very easy to obtain at least a 70 if you work on that retest. And then after that, of course, do the Delta Math assignment.